Hello everyone. Today, we'll discuss electric field lines, which help us visualize electric forces. These lines show the direction and strength of an electric field, similar to how a wind map shows air movement.
Imagine the flow of wind. Even though we can't see the wind, we can map its direction using arrows. Similarly, electric field lines help us visualize electric forces.
In 1830s, an English scientist named Michael Faraday introduced the concept of field lines as an aid for visualizing electric and magnetic fields.
As we all know, like charges repel and like charges attracts.
If you imagine any charged object, it will always have its own electric field all the way around it. Just like masses have gravitational fields, and magnets have magnetic fields. To understand why this is important though, let's imagine that we have two particles, one with a positive charge and the other with a negative charge. Although you can think of their electric fields as diffuse areas of influence all around them, in physics we show them with field lines, which are just lines with arrows on. And importantly, the arrows always go from positive to negative. So they go out of our positive particle, but into our negative particle. The other thing to remember when you're drawing them is that you have to draw them at right angles to the surface, so perpendicular like this. And if you're asked to draw them in the exam, make sure you show a fair few, for example 8 like we have here. Now the strength of the field is strongest close to the particle, and it gets weaker the further away you get. So as charged particles get closer together, their electric fields will start to interact more and more. If they're oppositely charged, like our particles here are, then there will be an attractive force between them, which we can call an electrostatic force, or in this case, electrostatic attraction. We can actually show this with their field lines by extending the field lines from the positive particle all the way over to the negative particle. Because remember, they always go from the positive to the negative charge. If instead though, we had two particles of the same charge, for example two positive particles or two negative particles, then the two particles would repel each other, because like charges repel.
Electric line of force is an imaginary straight or curved path along which a unit positive charge tends to move in an electric field. After observing the experimental patterns, the properties of electric lines of force were stated. Electric field lines originated from a point charge or infinity and terminate on a negative charge or infinity. If there is a positive charge in its surrounding, electric field lines will be in radially outward direction. Electric field lines have a tendency of termination towards a negative charge, thus lines will bend and terminate towards the negative charge. If charge magnitude is more, bending will be more. Similarly, electric field lines also have tendency to bend away from the positive charges. Number of electric field lines originating or terminating is directly proportional to magnitude of charge.
Properties of electric field lines. First, electric field lines are imaginary. Second, they never intersect at each other. Third, if electric field is stronger, field lines are closer. Fourth, electric field is perpendicular to the surface of charge.
To summarize, electric field lines help us to understand how electronic forces work. They follow strict rules and are used in many real-world applications, from weather phenomena to electronics. Next time you see lightning or use an electronic device, remember how electric fields play a role.